This is a solution for the mock exam for quadratics. Number 1, the graph of the quadratic function f of x equals 3 plus 4x minus x squared intersects the y-axis at point A, right there, and has its vertex at point B, right there. Part A, find the coordinates of B. So they want to find the coordinates of the vertex. Okay, first of all, in this class, whenever they give you a function, what's the first thing you do? You're going to put it in the calculator, even before you read the first question. So even before we read part A, we're going to put this in the calculator. So we go to y equals, and we're going to put in, remember f of x is just saying y equals, so y1 equals 3 plus 4x minus x squared. And remember, this is a quadratic, just like we've been studying this unit, but we don't even care. We just put it in the calculator anyway. This is why in this class we can immediately use these techniques to apply to different functions, because we're going to use the same calculator function to analyze all the functions. Okay, so we have a graphed parabola, which is actually the same parabola, and we want to know the coordinates of B, which is just another way of saying the coordinates of the vertex. So let's find that. Remember, to find the vertex, we either do second calc minimum or second calc maximum. In this particular case, that it opens down, we're going to do second calc maximum, because the vertex is the maximum point. So here we go, second calc maximum, which is option 4. And then left bound, we're going to put the cursor slightly to the left of the vertex, and then we hit enter, and then we put the cursor slightly to the right of the vertex when it asks us right bound. A little bit more, a little bit more. That's good enough. Hit enter. And then it asks us to guess. It doesn't matter what the guess is, because there's only one maximum point here. There it is. The maximum is 1.999999, y equals 7. Now remember, 1.99999, if you round it to 3 significant figures, is just 2.00, which is 2. Okay, so the vertex is 2, 7. Okay. How do you know when you can round 1.999999 to 2? Well, look how many 9s there are. I mean, if you round to 3 significant figures, if you say, okay, 1.999, okay, this is my 3 significant figures. The next digit is 9, so I need to round this one up. If I round this one up, it's going to be a 0, and then that's going to make this 0, and that's going to make this 2, so it becomes 2.00. Question answered, right? Okay, so that is the vertex. Next question. Next question. Another point C, which lies on the graph y equals f of x, has the same y coordinate as A. Okay, plot and label C on the graph above. And I gave you a hint here that parabolas are symmetric. Durr, you say. I already knew that parabolas are symmetric, but I'm reminding you that right here because you may need that information. So another point C, which lies on the graph of this parabola, has the same y coordinate as A. What is the y coordinate of A? It's about there. What is exactly the y coordinate of A? Well, I guess I could see using the calculator. Okay, it happens that A has an x coordinate of 0, right? So if I want to see the y coordinate of A, there's a couple ways to do that. One of the ways is I could just do trace 0. If I do trace 0, I can go directly to this point A, which is the y-intercept, and the answer is y equals 3. Okay, so this is actually 0, 3, if you were wondering, which means that this point here is also something, 3. All right? Okay. Another way you could figure out what the y-intercept is, remember that if we put this function in the form ax squared plus bx plus c, then c is the y-intercept. Now, is this in ax squared plus bx plus c form? No, because the ax squared is at the end. So if we reverse it and we put negative x squared first and we put plus 4x second because the x comes second, and then plus 3, this would be ax squared plus bx plus c form, and in that case we know that the c value is equal to 3, so the y-intercept is 3, and hey, the y-intercept is 3. Okay, another way you could do it, the last way, is to do second table. If we do second table, we can see that at the x value of 0, the y value is 3, so the y-intercept is, once again, 3. Okay, last thing it asks, we've already labeled c. C is right here. Okay, find the x-coordinate of c. The x-coordinate of c. Okay, so there are several ways to do this one. Okay, one of the ways is to use the fact that the parabolas are symmetric. Okay, so one of the ways we could do it is we could say, okay, where is the vertex? The vertex is 2 units over. If the vertex is 2 units over, that means the distance to point A and the distance to point C are the same, which means that A is 2 units away and C must also be 2 units away, which means that this would be 4, right? Another way to do it would be to check the table. We are already on second table. Let's look on the table to see if we can find the points with the y coordinate of 3. 0, 3, we knew that one. If we scan down, look, 4, 3 also is on the quadratic. So we've done it a couple different ways. We know that the other point is 4, 3. So we could just write that the x coordinate is 4. Okay? There's another way to do it, which is using the intersect function. I'm not going to go through the whole thing, but I'm just going to say really quick that if you put here that the y value is 3, and you graph both of these functions, one of them being the original quadratic and the other being a horizontal line at y equals 3, and you find this intersection here, guess what it's going to be? It's going to be 4, 3. So that's the last way. All right? All right. Are we done with this page? We are. All right. Number 2. The graph of a quadratic function f of x intersects the horizontal axis at 1, 0, and the equation of the axis of symmetry is x equals -1. Okay. Now, remember what I said. If they give you a function, immediately graph in the calculator. Do they give you a function here? No. So this must be a slightly challenging problem that we can't put in the calculator and get the answers to immediately. Hint, draw a picture. Okay. Part A, write down the x-coordinate of the other point of the graph, where the graph y equals f of x intersects the horizontal axis, also known as the x-intercept, right? Okay, well, it said to draw a picture. I don't know what to do yet, but let's draw a picture like it says to. The graph of a quadratic function f of x intersects the horizontal axis at 1, 0. So at 1, 0, I'm going to draw a point, and it's going to be the one of the x-intercepts of the quadratic. Usually a quadratic has 2 x-intercepts if it has at least one. And the equation of the axis of symmetry is x equals -1. Remember, axis of symmetry we usually draw with a broken line, a dotted line. So this is at -1, and this is at +1. We know that the quadratic has its axis of symmetry at -1, and it has an x-intercept at +1. Okay, so we know that it looks kind of like this, right? Might be upside down too. So what do we know about the distance from here to here and here to here? We know it's symmetrical, just like in the first problem, right? So we know that this one is 2 units over, so we know that this x-intercept must also be 2 units over. So if we're counting 2 units to the left from -1, that would be an x-coordinate of -3. So the x-coordinate of the other point where the graph intersects the horizontal axis, also known as an x-intercept, is at x equals -3. Okay, and we found it using symmetry. Okay, symmetry from where we think the vertex might be, although we don't know if the quadratic opens up or opens down. Part B, y equals f of x reaches its maximum value at y equals 5. Oh, now we know that it opens down because they just told us that this vertex is at height 5, because they said the maximum value of the quadratic is at y equals 5. So that means the vertex is at y equals 5. Write down the value of f of -1. Okay, so we just from our drawing, we can see immediately that f of -1 would be equal to 5, right? Because the height of the quadratic is 5 at x equals -1, because x equals -1 is the axis of symmetry, which means the axis of symmetry contains the vertex, and the vertex is at y equals 5. So they really told us in a roundabout way that the y-coordinate of the vertex is 5. They told us that the maximum value had a y-coordinate of 5, and we know that the maximum coordinate has to be the vertex. And we know that -1 is the axis of symmetry, so we know that the x-coordinate of the vertex is -1, so that fills in all the blanks, and then we can say, oh, what's the y-coordinate when x equals -1? Well, it has to be y equals 5, because basically what they're saying is, what's the y-coordinate of the vertex? So, 5. So we've just found out that the vertex coordinates are -1, 5, because the axis of symmetry is -1, and the maximum y value of the quadratic is 5. Find the range of the function y equals f of x. Okay, remember, range is all the valid y values. So, valid y values, of course, include 5, because the vertex is at 5. Do they include values below 5 or above 5? Well, since the quadratic opens down, we know that it only includes the y values below 5. Now the question is, do we write y is less than 5, or do we write y is less than or equal to 5? The reason why we would write y is less than or equal to 5 is because the vertex is also a valid point on the quadratic, and it has a value of exactly y equals 5. So we want to include y equals 5. So instead of just putting y is less than 5, we would put y is less than or equal to 5. Okay? Remember range? All right. And since it's range, we're going to use y and not x. If it was domain, we would use x. By the way, what's the domain of a quadratic? The domain of the quadratic would be all real numbers, because it extends infinitely to the left and the right. Even though it looks like it might end here, it actually goes to the left forever, it goes to the right forever, so the domain would be x is all real numbers. I'm just giving you that information. Additionally, you wouldn't write that here because they didn't ask us. Let's go to the next one. This is a challenge problem. Number 3, the graph of y equals 2x squared minus rx plus q is shown in the domain -5 is less than or equal to x is less than or equal to 7. What does that mean? That just means that the valid x values go between -5 and 7, as they demonstrated here. Do you see how it cuts off right there? It cuts off right there. It's because they specified a domain that was not x is all real numbers, so they cut the thing off. Okay, can we put this in the calculator? No, we can't, because they put a bunch of variables in here instead of numbers. They are not letting us put in the calculator, so this might be a slightly challenging problem. So let's read on. The graph cuts the y-axis at 0, 4. Write down the value of q. Okay, so if we know that the graph cuts the y-axis at 0, 4, that means that what we know as the y-intercept is 4. If the y-intercept is 4, what do we know about the value of c for ax squared plus bx plus c, which is a form that we can write the quadratic in? It would be c equals 4, right? The c value is the y-intercept, as we learned in the investigation. Since the c value is the y-intercept, we can assume that the y-intercept of 4, the 4 value would be equivalent to c. Now, if we line up ax squared plus bx plus c with our original equation here, we can find out some things about ax squared plus bx plus c. First of all, we can see that q and c are equivalent because they line up together. We can also see that -r and +b are also equivalent because they line up together. We can also see that 2 and a are equivalent because they line up together. Okay? So let's see if that helps us answer any other questions. They said to write down the value of Q. Hey, we know that Q is equivalent to C. We know that C is equal to 4, which means that the Q value is 4. Let's see what else they ask us. The axis of symmetry is x equals 2.5. Find the value of R. The value of R is actually the value of negative B, right? Because positive B is equivalent to negative R. So if we find out the value for B, we can find out the value for negative R. How do we find out the value for B? Well, there's a hint here, which says, use the expression for the axis of symmetry from the formula sheet for part B below. If you look on the formula sheet, you'll see that the formula to find the axis of symmetry is x equals negative b over 2a. It says that maybe we can use this to find out the value of b, or I'm sorry, the value of r, which we know is we know that negative r is equal to b. So if we can find out what b is, we can find out what r is, because they're related. First of all, we can't fill in negative b over 2a because we don't have a value for b. But can we fill in the other two values and make an algebra problem out of it? Well, do we know the actual value of the axis of symmetry? Yeah, they just told us this. They told us it's 2.5. So that means that we can fill in 2.5 in for x. Do we know the value of a? Actually, we do. We just looked at it here, and the value of a is equivalent to 2. So we could fill in 2 for a. So that means we filled in the x value, and we filled in the a value. The only thing we don't have is negative b. So if we fill in those two values, we can actually solve for it using algebra. 2 times 2 is 4, by the way. So negative b over 4 is equal to 2.5. Let's solve for b. First of all, we have 4 in the denominator. We don't want that. We multiply both sides by 4. 4 times 2.5, if you do that in your calculator, you find out it's 10. 4 divided by 4 is 1, so they cancel out. So we're left on the right side with just negative b. Negative b equals 10. Well, b is equal to negative 10, right? If b is equal to negative 10, what is negative r equal to? Well, negative r is the negative of b, right? Negative r is equal to b. So if negative r is equal to negative 10, I put negative 10 in for b, then r is equal to positive 10. A little bit of algebra there. That's why I said algebra challenge. So r is equal to 10. Okay, now we have all the values necessary to graph in the calculator, and it should make the rest of the problem much easier. Okay, so let's take a look at it. Instead of putting y equals 2x squared minus rx plus q, which they have above, minus rx plus q, now we can plug in all the values that we actually know. Remember, q is 4. Remember, r is 10. So negative rx would be negative 10x plus 4, and the first part would be 2x squared. There is our function. By the way, it asked us for r, what's the value of r? There's r equals 10. Okay, and then I just did this because it said, oh, now you should be able to graph in the calculator. I need the function to graph in the calculator. Here is the function that I'm going to put in the calculator. Okay, I'm going to put it into y1. So into y1, I put 2x squared minus 10x plus 4. And I graph it. Okay, and it asks me what's the minimum value of y. Well, the minimum value of y is here down at the bottom. And what's that also called? It's called the vertex. And how do I find the vertex or the minimum value? I do second calc minimum, of course. Option 3. left bound, just somewhere to the left of the vertex. Anywhere to the left of the vertex is fine. Then it asks me for the right bound, so I move the cursor to the right side of the vertex. And then I hit enter again, and then the guess doesn't have to be in any specific place. I just hit enter, and the minimum value is 2.500004, and y equals negative 0.5, I think it says. So I'm just going to write those down. The vertex is equal to negative 2.5, and that's not a surprise because it says it right there. And I'm sorry, it's not negative 2.5, it's positive 2.5. Right? And then the y value is, it's not negative 0.5, I think it's negative 8.5. You know, this is like too small for me to read, even with my reading glasses. I'm getting blind. I'm gonna, just make sure by looking at second table because the numbers are printed bigger. Okay, so what I want is the x value of 2.5. Since it doesn't have it here, I'm gonna put plus 0.5. And now I can kind of see it. Yeah, I think it says negative 8.5. Really hard to see. Really hard to see. Is that better? Okay. Okay. Back to work. I'm finally satisfied that it actually says negative 8.5. By the way, it says to write down the minimum value of y. The minimum value of y would be the y value of the vertex, so it would be negative 8.5. Okay. Now we go to the last page, which is a 12-point problem. Okay. You haven't seen too many of these long problems, but this is one of the long problems on the IB exam. Paper 2 has all the long problems. Paper 1 has all the short problems. They both use the calculator. Okay, a small manufacturing company makes and sells X machines each month. The monthly cost, C in dollars, of making X machines is given by C of X equals 2,600 plus 0.4 X squared. So this is cost. This is a difficult problem because I don't think that most people, unless they take IB business, realize that there's a difference between price and cost. Cost is how much it takes for a company to make something. Price is what they charge for it, which is probably going to be somewhat higher than the cost so that they can make a profit, which is the difference between the two. Okay? So C stands for cost, and there's the function for cost, and it depends on how many machines they're making, okay, which is X. The monthly income in dollars is obtained by selling X machines is given by blah, blah, blah. So they're giving you a lot of business terms here, and they're actually telling you exactly what to substitute into what. So even if you don't understand what each thing is, you can still do this problem. But if you're a business, IB business student, then this problem should be particularly interesting for you. The monthly income is how much the company takes in every month, usually by selling products, okay? So in this case, it says that the total income is, or the monthly income is based on how many machines it sells, which is X, okay? So depending on how many machines X it sells, you can figure out how much they make in income. And if the only thing they're getting money for is selling X machines, then you also know that the income is related to the price. Okay? Show that the company's monthly profit can be calculated using the quadratic function. Hint, profit P is income minus cost. Okay, so the profit P is equal to this. Whenever it says show that, basically this is an algebra problem. Okay? What it means is, can you do all the algebra necessary to find this answer? Is it okay to use this answer to find this answer? No, they're giving you the answer. They want you to use all the information they gave you before to find this answer now. Okay? And what you're going to do is you're going to say profit P is equal to income minus cost. And so you're going to say income is income 150x minus 0.6x squared, right? And then we know it's minus the cost, which is 2600 plus 0.4x squared. And then we're going to subtract one from the other and combine like terms. Since these are like terms, then we're going to actually subtract the coefficients. This and this are not like terms because this has an x in it and this one doesn't. Okay, so for 150x and 2600, we just write them out again. 150x. Remember, the negative sign is distributed to each of the elements that are inside the parentheses. So it's actually negative 2600, okay? And then we're going to combine these two, okay? First, what I'm going to do is just going to write everything without parentheses. So I'm going to take off the parentheses, minus 0.6x squared, minus 2600, because I distributed the negative sign to 2600. Then I distribute the negative sign to 0.4x squared, so I put minus 0.4x squared. Now I'm going to finally combine these like terms. So I just write 150x, and then I just write negative 2600 or minus 2600. And now I'm going to combine like terms, negative 0.6x squared minus 0.4x squared, negative 0.6 minus 0.4 is equal to negative 1. And I'm done. Look, negative 1x squared, negative 1x squared. 150x, 150x, negative 2600, negative 2600. I did it. I got the answer that they told me I was going to get, and I didn't use it to get it. I took the hint, which is profit equals income minus cost. I plugged in the income and the cost, and I eventually got the expression that I was supposed to get. Yes, show that means algebra problem. Okay, why do they give you the answer in a show that problem? The reason why is because they want you to have this expression to do the subsequent parts. They don't want to make it so that if you don't do part A, you can't do part B, C, D. So if you see a show that and you think it's really hard because you're not good at algebra, just skip to the next letter. And then you probably just can use the answer for the show that to continue on. The maximum profit occurs at the vertex of the function p of x. What function is p of x? It's right there. They gave it to us. Even if you didn't find it in the show that, you already know the answer. How many machines should be made and sold each month for a maximum profit? So basically what they're saying is, how many machines is x, right? So they're saying, what should be x so that p is a maximum? Doesn't that sound like a vertex? Okay, so first let's put p into the calculator because we have an expression for p, right? So we'll go to y equals. We will type in negative x squared plus 150x minus 2600. And then we will graph it. Now, usually these kind of problems where they work with real scenarios such as cost and that kind of thing, it doesn't fit in our standard graph. Remember how I said 80% of the problems you're going to do fit in the standard graph between negative 10 and 10x and negative 10 and 10y? Well, this isn't one of them because look at the values they're using. 2,600, the thing is huge, okay? So what we're going to have to do is we're going to have to change the window size so it's working with values about this size. Well, we can see that we're working with thousands, right? So maybe what we should do is we should change our window size so that we're working with thousands also. Now remember, we're working with number of machines and we're working with price, and both of those should be positive. So I'm not even going to increase the negative part of the graph. I'm going to change x max to positive 1,000. And I'm going to change y max to positive 1,000. And then I'll see what I get. See if I can actually see something, because the last graph I did, it was like totally off the screen. Oh, now I can kind of see something, right? But I actually have it a lot shorter than it needs to be, and it's a lot wider than it needs to be. So let's do this first. First, what I'm going to do is I'm going to adjust the window size so I'm not wasting so much space to the right here. So what is your strategy for adjusting the grid? You should always try to adjust the X first and then try to use zoom fit. Zoom fit is the easiest way to do it. Okay. the reason why I don't do zoom fit right now is because the x is not adjusted yet. So I'm going to try to adjust the x first. So instead of 1,000, it looks like I don't need that much. Maybe I need like a fourth of that. So I'll put like 200. Now I'll graph again. Okay, so that's more like it, right? Now what I'll do is I'll do zoom fit, which is the easiest way to adjust the y value. So after you adjust the x value so they're about right, I'm going to do zoom fit, which is option 0. Okay, and now it draws kind of what I want. Now remember, I want to find the vertex because the maximum profit occurs at the vertex of the function. So I'm going to do second calc maximum because it's the maximum profit. It's the vertex and it opens down. And first thing I'm going to do, I'm going to put the left bound to the left of the vertex. It kind of is going to take a while to click this to the left of the vertex. So I could just put in a number. I could put like 20 or something. But I think I'm okay. Okay, and then I go to the right side. I could put in a number. I could put like 150 or something. I'll just type 150. 150. Enter. Okay, and then the guess. Guess doesn't matter. So I just hit enter. And the maximum value is 75.00003 and y equals 3025. 75.00003 rounds to 75. So my value for the vertex is 75, 3025. So the x value is 75, and they want the x value, right? Because it's how many machines should be made and sold each month for a maximum profit. The x value would be the answer because that x value is the number of machines. So 75. And then it says, if the company does maximize the profit, what is the selling price of each machine? And it says, hint, the price per machine is income divided by number of machines. Remember price? So price is the amount that they sell it for. Cost is the amount it costs to make it for you IB business people. So I can find the price per machine by finding income divided by the number of machines. What's the income? The income is that expression we had before, which is 150x minus 0.6x squared. So I'm going to write that down. Income equals 150x minus 0.6x squared. And then I'm going to divide that by the number of machines, which is divided by x. Okay? And it says, what is the selling price for each machine? I know that this is dependent on x, and I know the x value, which maximizes the profit, is x equals 75. So I'm going to put in 75 in here, and that's going to give me my income divided by number of machines, which is equal to 150x minus 0.6x squared divided by x. I forgot to write that that's divided by the number of machines. Okay? I'll just put x here because we know that that's x. So let's do that. So there's two ways to do this. You could put this expression in y equals and then look at the table or something. But we're only looking for one number, I think. So we'll just type it into the regular screen of the calculator for once. Okay, so I'm going to put in 150x, which is 75, minus 0.6x, which is 75, squared. And that would be the income, which is 7875. And then I'm going to divide by x, which is 75. And the answer is 105. So the price for one of the machines is 105. Okay. Anything else? Yes. Given that P is equal to, they give us another function for P, and this function for P is the same as the other one, but what kind of form is this? This is factored form, right? The one above is standard form. Okay, now what are they going to ask? Find the smallest number of machines the company must make and sell each month in order to make a positive profit. Okay, so what do they mean by that? They mean that we looked at the graph of P already, right? It looks like that. It says find the smallest number of machines, which is the X value. find the X value, which the company must make each month to make a positive profit. What does a positive profit mean? That means like any point on this curve that's above the x-axis, because this is the profit curve. When is this curve above the x-axis? Well, it's above the x-axis between the two x-intercepts. And you might say, oh, to find the x-intercept, all I need to do is do second calc 0. I could do second calc 0 on the left side, second calc 0 on the right side, and that'll give me the two x-intercepts. The reason why they gave it to you in this form is they're trying to give you a hint that actually you already have the x-intercepts here, right? So the x-intercepts look like they might be 20 and 130, okay? Because those are the numbers which are paired alongside the x. Remember when you have x minus p times x minus q, that those are the x-intercepts, p and q? In this case, you have x minus p, and then you have q minus x, which is a little weird, okay? So, but that's basically what you need to do. You need to look at these two numbers, and you're like, oh, those are the x-intercepts. So the point at which the function goes above the x-axis the first time would be 20, and the point at which it goes below the x-axis would be 130. Let's say that you weren't clever enough to see that the first try. Remember that you can just take the p function, and you could either type in this new p function, or you could just keep the p function the same as it was before, which is standard form. They're both the same. And then you could just do second calc 0 to find the x-intercept, because that is the point at which it starts becoming positive. So second calc 0, and then we're going to move the cursor so that's slightly to the left of the x-intercept. Let's just say 0. And then we're going to move the cursor slightly to the right of the x-intercept. We'll say 30. And then we hit enter. And it tells us that the 0 point is 20, 0. Hey, 20, 0. We already knew that. Okay? So find the smallest number of machines the company must make and sell each month in order to make a positive profit. We might say that the answer is x equals 20. That is almost right. Why is it not quite right? Because what is the profit at x equals 20? It's actually 0, because it's on the x-axis. So in order to make a positive profit, it has to be slightly above the x-axis, which means that it should be at least one more. So we'll put x equals 21 instead of x equals 20. Okay? That's pretty tricky. This was a pretty difficult problem, maybe an interesting problem for the IB business people. And I am not going to give you a problem like this on the exam yet, but eventually you might have one. So please make sure you understand it.